It is possible to determine the amount of nickel in a solution by various methods, but here we're going to look at a compleximetric titration. The titrant in this case is ethylene diamine tetracetic acid, thankfully and for obvious reasons usually called just EDTA. This follows on from the previous video about complex formation in that it involves the formation of a complex between the EDTA ligand and the nickel ion. EDTA is a polydentate ligand with 6 binding sites. As you can see, it can surround the nickel, or another metal ion, displacing, in this case, all 6 ligand binding sites. As usual, we need an indicator, in this case a compleximetric indicator. This is another chemical that can form a complex with nickel. Here we're using eriochrome black tea. When added to the nickel solution, the eriochrome black tea binds to it, forming a yellow complex. As EDTA is added, it initially complexes with the free nickel ions in solution. Once that has finished, it complexes with the small amount of nickel that is currently complexed with the indicator, because it has a greater affinity for nickel than the indicator, and so replaces it. The free indicator produced at this point is a different colour from that complexed with the nickel, and the colour change produced is the end point of the reaction. I'm assuming you're all familiar with the normal process of a titration, so by way of a change I'm doing a microscale titration this time. The burette is replaced with a Pasteur pipette that is held in the jaws of a laboratory clamp. First of all, we need to calibrate the pipette. We fill it to the 1 cubic centimetre mark with water and then count the drops as we squeeze out the liquid. Do this a few times to make sure of the reading. It's usually around about 22 to 24 drops per cubic centimetre. We then fill that same pipette full of EDTA and position it held gently in the jaws of the clamp. Then we add 1 cubic centimetre of nickel solution to a small universal bottle, or you could use a test tube I suppose, along with some sodium hydroxide, as these titrations work better in alkaline solutions, and a small amount of the indicator, eriochrome black tea. As you can see, it goes yellow. Now we squeeze the clamp gently to add the EDTA titrant 1 drop at a time, making sure we keep count of the drops. As we get near the end point, you need to mix thoroughly after every drop. And now we have the end point. The solution goes purple. Once the reaction has finished, we can divide the number of drops added by our test value to get the value in cubic centimetres, and then we just carry out the calculation as we normally would for a standard titration. To be fair, this is not quite as accurate as a standard titration, but it's still pretty close, and it does have the great advantages of being faster, easier and less expensive to carry out.